Okay, we're recording this lecture 10 webcast for algebra with the midterm review. I'm switching over to Karen. Hold on.
And good morning, everybody. Remember, there's a little lag, so my screen will pop up in a sec, okay? It should be any second probably showing up. Can y'all see it? Hopefully you can.
And I'm going to mute myself out. Thank you. Have a great session.
You too. So, great to have you guys. This is going to be for Lecture 10 and serve as a midterm review as well. So, I'm going to ask you guys if you have any questions on that, on 10. So, let me pull up my questions box and see what you guys have for me, just to try to keep this, I don't want to say brief, but I want to be able to get to other questions too, because we want to keep in mind that the midterm covers from 6 through 10, lectures 6 through 10. Yes, I can do that. Yeah, Michelle, a lot of factoring. I hope that's why I'm trying to get to, when I get to that. We can do that first if y'all would like. We're going to go through 10. So I think the factoring is in my experience, out of all these skills on this particular midterm, factoring is going to be one of the bigger issues. So something like page 307, I'll try to do that. Let me make note of that. Let me see, page 307, example 3. I will try to do that. I'm going to pull that up in a bit, okay? Let me kind of get to some basics. I'm pulling that up. I'm pulling up your homework right now so that I can just have that handy. That's what I have, my spare computer that I had the other day. That's what that's here for, so I can kind of pull things up on the side and not have to switch my screen from y'all. Why don't we do a little warm-up problem, though, okay? And let's see, I'll come back to this page. Let me minimize the GoToWebinar screen, okay? And let's see. Oh, F11. Oh, come back. There you go. Okay. So let's kind of do a little rule of exponent warm-up. This, like I said, just a little warm-up problem. We're going to go to factoring next, but rules of exponents are everywhere in everything we're doing, aren't they? So keep that in mind, you know. Make sure you don't forget some of the skills that you have to deal with, you know. We kind of take those for granted sometimes. Hopefully not this time. Okay, let me get this thing up. All right, come on. Come on. All right, there we go. I got it. So, okay, get my pen working. All right, there. That should do it. Okay. Okay, so can everybody see? I drew a smiley face. Everybody can see that, I hope. Let me know if you cannot see my writing on the screen, okay? And so what I'm going to do is I'm just going to write on here one of the things that kind of, actually, I think I'm going to take a problem from your homework so you can kind of, this might help, okay? So, all right. This will be from, actually from 10. So it's number 6 in homework 10. Well, it's similar to number 6, okay? So this will be like an example. So to help with number 6 in 10. So if we have this, let's say we have x to the 3rd power, y to the negative 2. Okay, and then let's raise that to the 2nd power, multiplied by x to the negative 2, y to the negative 1. Let's raise that to the negative 2. Okay, and then that's good for now. Let's just have that. Okay, so what do we do here? Okay, if you look inside the parentheses, the basis, by the way, the base is what's being raised to the exponent, right? The bases don't match, right? So if we're just looking, let me highlight where I'm looking right now. Right now I'm looking inside here, okay? I'm kind of comparing my bases to see, but we have an X and a Y base. So I can't do anything with that. So I go outward to the 2 that's attached to the parentheses. So that's kind of where my eyes go next with the order of operations, okay? All right, so what happens here is this 2 kind of, I guess you could say it is like distribution. It's not quite distribution, though. It's not the formal name of this. But what I called it in the previous lecture was raising a power to a power. And these are multiplications inside these parentheses. Both sets of parentheses, there's multiplication. So every factor inside the parentheses is going to be raised to that second power. Okay, so what that looks like is this. And this will be a step you probably won't usually write. So watch. I think what I'm going to do is this. I'm going to write it in a gray color or something. This next step would look like this. Let's see, where are you, pencil? There you are. So we would have x to the 3rd power would be raised to the 2nd power. And y to the -2 would be raised to the 2nd power. And so on and so forth with the other set of parentheses too. Okay, so x to the -2 would be raised to the -2. Okay, and then what? Y to the -1 is then raised to the -2. Okay, so that's like a little median step. Okay, you don't usually write this step, but to explain why things happen, this is what happens. Okay, so where our eyes go next is here, right here. Raising a power to a power, we multiply, right? So for each of these, there's 4 items. We're going to multiply these 4 things, sets of exponents. Okay. All right, so for the first one, we'll have x to the 6th power. Okay. And look, I'm going to show you this too. If you want to go ahead and put your x's together, I'm going to go ahead and put my 2 x's together, okay? X, then the other x is -2 times -2, right? That's going to be a +4 exponent, right? Okay, and so what I'm going to do, let's see, let me get green over here. I'm kind of just highlighting what I'm doing here. So it's multiplying. I'm going to have y to the -4th power, right? The 2 times 2. And then y to the -1 times -2 becomes y to the +2. Multiply the exponents when we're raising one power to another power. Okay? And so next step is the very first rule of exponents. Let me drag that box of exponent rules down here. Come on down, exponent rules. Okay, so what we're looking at so far, okay, so far we have used this, in this box we've used this rule combined with number 4, 3 and 4 kind of combined here. And then now we're about to go into rule 1, the very first one where we multiply straight across. The forms with the like bases, those are the guys that we add the exponents. Remember, we have to have a base of x on both, right? X here, X here. Next step, we can add that 6 and 4 and tack it onto a single x factor. Okay, so x, 6 plus 4 is 10. Okay, and then finally we would have what? Y to the -4 plus 2, right? So let me get my bearings here. So y to the -2. The question is this the most simplified answer? Is this simplified, you guys? Can y'all tell me? No, it's not, right? That's correct. We would have to make all exponents positive. You cannot leave a negative exponent. Okay? So don't leave a negative exponent in the answer, okay? So we must, let me make a little red note on that, okay? So for this to be all the way simplified, for you to get your total credit, okay, so you must not leave negative exponents. In your answer, okay? Okay. Okay, so in other words, it's not fully simplified. Okay, so what do we have to do here? So we would have to go ahead and make that negative exponent positive by crossing the fraction bar. Remember that you don't see a fraction bar here, but it's there, right? So we want to kind of just remember that this is over 1, okay? Kind of keep in mind that's over 1. So what we do is, if the exponent is positive already, we leave it where it is, right? X to the 10th power remains in the numerator. But this y to the negative 2, this guy's got to go downstairs and it'll become positive, simply. Okay, so this is my simplified answer. So keep that in mind. You don't want to leave negative exponents in your answer. It's not totally simplified if you have a negative exponent left in there. Okay? Yes, I have a question. Let me get that. Okay. Where's my question? Okay. Yes, multiplicative inverse is reciprocal. Let me show you something on that. Okay. So let me scroll down. Give me a little room. Alrighty. Put that back. Okay. I think I might have scrolled too far. So let's have another example with that. I may ask you, what if I'm asking you to find the multiplicative inverse? Yeah, that's nice handwriting. Multiplicative inverse of, and let me see, let's have, let's say, wait, let me find a good problem. I don't want to give you exactly what's in the homework because you guys kind of need to do that. Let's just say 2x minus 1, okay, for lack of a better example right offhand. Okay, so what you would want to do, the symbol that you would use here would be this. We would write, you could do this, 2x minus 1 to the negative 1, right? When you see a negative 1 on something, okay, this would be another way actually to give you the same problem, to find this negative 1 exponent is telling you to find the negative, to find the reciprocal or the negative, what am I saying negative for? I'm sorry. The multiplicative inverse of 2x minus 1. Okay, so here we are. So let's put that little note. Okay, so negative 1 exponent, okay, means find the reciprocal. Okay, which is also the multiplicative inverse. Okay, so how do we do that? So remember that this is over 1, right? And you just simplify that negative 1 exponent, really. So it becomes 1 over 2x minus 1. Now really I can't do anything with this as it is given to me here. Okay? And so really this is what I would give for my answer here. Okay? All right. Questions, let me see. Exercise. Yeah, let's see. Okay, 10. Yes, let's get into some factoring, okay? Most definitely, Viv, I got you. Let me get into some good factoring examples with you guys now that we're kind of warmed up with this. Okay, let me go back to where I was before. I'm going to take this. Let's see. I'm going to move this downward. Okay. All right. We'll come back to this stuff after a while. All right. Come on down. Going. Okay, so come on up. Let me make myself some writing room. Let's talk about factoring. I want to talk about the steps of factoring, okay, before I go into an example. And I'll try to fit as many examples of this as I can. Okay, so there are some steps you have to follow for factoring to be thoroughly or completely factored, okay? All right, so kind of that's the deal. You want to a lot of times you read the directions and they'll say completely factor this polynomial, okay? Okay, and I should put the word completely, completely in the front of that, just to kind of make that point, okay? So, all right, so let me get this example up for y'all, okay? All right, the first thing you want to do, okay, when you are factoring is, let's see, number one, okay, a polynomial, we want to make sure we have descending order, okay, or standard form. Put it in standard form if it's not in standard form already. And last time we talked about standard form as being descending order of the exponents, right? Okay, so for example, let me get this example up. Okay, so let's see, right here, this is a good, right there. Let's say we have, okay, let me write this on the side. Where's my pen? Okay, sorry guys. So there you are. So for example, if we have something like this, 2x plus 2x squared, okay, this is not in descending order, right? So we would want to simplify this by writing it as the highest exponent on x should be first, right, and then on down. So there should be like a little countdown, right? So we don't have to put the 1 though. So descending order is important. You need that descending order for trinomials as well, okay? And of course, the next step, the next thing you want to do, let's see, 2, come on. It wants to number it, I have to let it number it. The second thing we want to do would be to factor out a common monomial factor, okay? So a common monomial factor, what is a monomial? A monomial is a single term, right? In other words, each term in the polynomial, if there is a common factor amongst those terms, we can filter it out into the front. Okay, so this would be an example with that. So this would be continuing our little example we have here. There is a common monomial factor of 2, right? And then we can take out, if all the terms have an x or the same variable ending, the same variable in common, we want to take out the smallest exponent's value of that. So if we have a choice, we have an x squared term and we have an x term to the first power. We want to take that smaller exponent. So here we'll take out a 2 and we'll filter out an x to the first power. And when you do that, you write what you're filtering out in front, open up a set of parentheses, and then you begin to undistribute that. So what that kind of is this, okay? What we do is we take the first term, and I'm going to try to put this on the side. I think it'd be better if I kind of write this on the side here. Okay. So like we're going to take the 2x squared, and we're going to divide it by 2x. And what is left over, right? The 2's cancel, the x cancels. I'm left with just an x, right? So think about it both ways. Once you do that, what times 2x gave me that 2x squared? Well, an x. Another way to think of it now, okay, we have the 2x. What times 2x gave me 2x? The identity of 1, right? So we do not put a 0 there. There's something there, right? A 1. To check your factorization on this type of factorization, always go back and redistribute that 2x back in, or whatever it is you filtered out. Redistribute it so that you make sure you got your signs correct and you've thoroughly factored it. Oftentimes people don't want to put that 1 on the end, okay, if that all comes out, if it's all getting factored out. Make sure you put a 1 in there. Okay? All right. Let's see. Okay. All right. So I'm reading your questions too. Trying to get all that out. So let's see. So the next thing you want to do let me put a little addendum on number 2, okay? One thing we would like, okay, if we have a trinomial that we're looking at and we're doing all these steps, we could go through all these factoring steps on a single polynomial if it's appropriate. So I'm going to say factor out a common monomial factor, and I'm going to put a little dot, 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 including a negative leading coefficient. Okay, let's talk about that. Coefficient. Okay, not the best typer, but I get the message through, I hope. Including a negative leading coefficient if necessary, okay? The reason I'm putting if necessary is this. When you go to factor a trinomial, that's with the x squared plus something x plus a constant. We want to have a leading coefficient. The front of that coefficient should be positive. Oftentimes you'll see this, okay? We're going to factor trinomials of the form, and when we get into quadratic equations too, you're going to start seeing this format I'm about to show you. Ax squared plus bx plus 10. I mean plus c. What am I saying 10 for? So this is one we're getting up to next, okay? So we want that a to be positive, that very first leading coefficient. That would be the numerical part of the first term, right? On the x squared term, a here in this format I'm writing on the top right of the page, a is my coefficient on the x squared term, right? It's the number part. We need that to be positive if we're going to be able to go through all of the rules and the methods that we use to factor. Okay, we want that positive, if at all possible. And this part makes it possible. So we can factor out a negative if we need to. Okay, and I'll try to get an example of that being a thing to do in coming up shortly, okay? So let's go to step 3 then, okay? All right. Step 3 would be to, I call the leftovers. Okay, let me just kind of show you what I'm talking about when I'm saying leftovers, by the way. It's a term I'm about to use. The part in the parentheses, after you filtered out this 2x in the example here, there's this remaining, the filtered part is what's in the parentheses. When we filtered out the 2x, when you hear me refer to the leftovers in my lecture, I'm talking about that. I'm talking about what's left in the parentheses once you factor out something, okay? So in what I'm going to type now is this. I'm going to type, you'll want to use an appropriate, because there are many ways we could go with that, appropriate form of factoring if needed on the leftovers, okay? Leftover, okay. All right, eek. The leftover portion of your polynomial. I'm just going to leave it like that, okay? And that means this, that's this. Let's go to it. Let me do this example. So let me take one similar to 10. Let me see. All righty. Let's do, okay. Okay, so let's do this. Let's go to, here's one. Okay, so let's do, I'm going to go ahead and do a trinomial for y'all, okay? Oh, I need color in my pen, don't I? So factor the polynomials. Let's just get a bunch of them. All right. So let's kind of get this. Let's put a bunch of them up here. Oh, did I put the wrong section? No, got it. Okay. So let's see, we're going to do, let's have this one A. I'll put a few up, okay? And while I'm writing these problems, you guys start working on them. See what you can do, okay? Always start with number 1 in the steps, okay? Because it's not until after we get to 3, that's when the whole factoring of that trinomial, any special form kind of factoring, grouping, all that comes after 3. You always have to go through steps 1 and 2. Always. Okay? And just when you think you don't have to go through them, you're going to have a problem where you should have gone through them and it was a trick. Okay? So always go through these first two steps. It'll save you a lot of grief. Okay, so first I want you guys to work on this while I write a few other problems down too. We'll have 3x squared y minus 6xy squared plus 12xy. Okay, so work on that, and I am going to write some more down. Okay, so go ahead and do that. And if you have a question, I want you guys to make sure you put it in the box. Okay, and I'm going to look up those other problems y'all were requesting too. So let me go see what's that problem. Okay, are y'all working on them, by the way? Y'all are getting that? Okay. Let's see, let me write another one. I can't see my pen very well today. Let's see what's going on. That's better. That will help. Okay. Okay, let's see, x squared plus 6x plus 8. Okay. Okay, so here we go. Let's look at these, okay? Here's what I have here. Okay, and also we need to go through that long division too. It's a big one. So factoring this polynomial here, okay, the first one, part A. What are my steps of factoring, by the way? Let's go back and review. Put it in standard form. There's two variables here, so that's kind of tough to kind of figure out. We'll kind of assume x is going to be the variable when there's an x and a y. Okay, so we want to, we would put it in descending as, we don't actually, when it says x, y in the problem, or a, b, or something to that effect, it's probably going to be okay for you. You don't have to start putting it in any different order yet. So hint, hint, on these problems you can kind of go to number 2. So now let's look for a common monomial factor. Okay, so let's look at the numerical portion of these guys. Okay, look at the 3, the 6, and the 12. And what is that greatest common factor? In other words, what's the largest number that is a common factor? That's a part of each of these. And I would say a 3 would be the one, right? 3, 6, and 12. Which of these, what number can be, let's see, I'm wording this backwards. These numbers are all divisible by what number? 3, right? That's what I'm trying to say, for lack of a better way to say it. Okay, so we can take a 3 out. So we're going to filter out a 3. Okay, so let me put my equal sign. Now, out of the x factors of each one, we have x squared, x to the first power, and x to the first power. Earlier, I said when you have that choice, but see, they all have to have some factor of x. Okay, so the smallest exponent on x is a 1. So I'm going to take only x to the first power to be factored out. Okay, and then finally, I have y to the first power, y to the second power, y to the first power. So I'm going to take a single y as well. And so now we just go through and looking at each term in the trinomial, and we kind of unfactor it. We say, what would I have if this were a distribution problem and I were the teacher, right? What would I have to write in the parentheses if that's going to be, if the problem the given problem is going to be like my key? Think about that. So first off, I have to have 3 items in here, right? 1, 2, and then finally a third, right? That's the end. So 3xy times what would have given me the 3x squared y? You can also think what's missing, right? What is missing here up in the front from what I'm filtering out? What's missing here that would have been here? Okay? All right, so the first parenthesis, let's see, the first term will be what? Just an x. Now check yourself. 3xy times x. Multiply the 2 x's, you should get this x squared, right? Okay, and that's correct. All right, so now 3xy times what would have given me this negative 6xy squared? Okay, well, and also remember on the side you could also do this, 6xy squared divided by 3xy. You could also do that. Okay, and you could kind of just get the what you need to be in the parentheses that way. Okay, so what's missing? A 2 and a y, right? Now multiply it back through in your head. We'd have 3 times negative 2, negative 6, x, and then y times y give me y squared. So we're good. So you kind of always want to multiply it through. If you go on the side and divide 12xy by what we're filtering out, that's the next one. Okay, so this, we'll have the 4. X's cancel and the y's cancel. So this one just leaves me with the 4. Okay, we didn't factor out a negative, so notice that the signs all stayed the same in the leftover portion, right? In x minus 2y plus 4, that's completely factored. That's as far as you're going to get with that one, and I would leave the answer looking just like it is. Okay? Oh, see my questions. Okay. Hold on a second. All right. You got it. Yes, correct. Good job, Michelle. All right. Now let me see. Let me kind of put this down here so I don't have to keep opening it up. All right. So now B. What is B? B is a special form. Hopefully you guys saw it. I'm thinking they did. Yes, I'm not mistaken. All right. What happened when you guys, we saw this before in the previous section. I'm going to kind of get to B in a sec, but let me make a little sidebar. Okay, and I'm going to come right above these problems. Let's see, right up here, I'm going to make like a little red box here. Okay, and what happened when we took the sum and the difference, we multiplied the sum and the difference of the same 2 numbers, and this is what I'm talking about. Okay, previously we had to multiply, or you were asked to multiply. We learned to FOIL, right? We learned to multiply 2 binomials. And we would have something like this. X plus 3, X minus 3. Okay? Now, what did we do? When we went to multiply these 2 things, we could do it a couple of ways. You learned to FOIL, that was first, outer, inner, last. But we also learned to do this. We did this. We would go X, and I'm writing this in gray because this is the medium, the little middleman term, excuse me, step that you would actually be doing. And FOIL, this is actually the long way of FOILing. It's the same thing. Okay, that should be minus 3. So what I've done here is I've taken each term in my first polynomial, the x plus 3, and I've distributed into the second polynomial. Okay? And so it's the same, you get the same result that you would get with FOILing, by the way. The reason I'm showing you this is you can extend this to a trinomial, whatever, any polynomial. This is really how you do it. Okay? But I'll FOIL from here on out. I just want to show you guys this. So, okay, what happens then is, let me get my dark color, I can see the pencil point better. Come on, go. Okay. So now what we do is we have what? First we have x squared minus 3x. Notice this is the same as first, x squared. Outer is minus 3x, right? Inner plus 3x. Look what's happened. It's the same thing as if I do it the technically right way. And then last is positive 3 times negative 3, which is negative 9. Now look what's going to happen here. I've got my middle terms, positive 3, negative 3x. They cancel out. So when you have the sum and the difference of the same two things in the parentheses, those middle terms, the outer and inner of your FOIL, they will cancel, and you end up with the difference, subtraction, between two perfect squared numbers. Okay? Knowing that, let's kind of go backwards. Notice where we came from on this problem we're working on right here, okay? Where did we come from? The two numbers that are being added and subtracted in my original problem are the square roots of the two numbers in my answer here. Okay? So knowing, kind of seeing this pattern, let's go to B. Okay? So now we kind of know what to do now. We know that the difference of two perfect squares, right? Let me write this down too. If you want to look it up and get more practice, I have worksheets and worksheets on this, by the way. If you want more practice, let me know. Difference of squares, two perfect squares, okay? All right. So we know, what is the square root here? This is going to be x squared, right? And the 4 is going to be what? That's a 2 that's squared. So you want to take the x and the 2. So whatever's being squared, the x and 2, those guys are what are going to be in my factorization. So we have plus x plus 2, and then minus. We'll have subtract 2. That's my factorization. If you have the subtraction between two perfect squares, this is how it works out every time. And look, let me give a B part 2. Okay, so we'll make this like a part 1. Okay. Make this a part 2. So now let's say if I have this, I might have 16 x squared minus, let's get bold, and maybe 81. Check this out. Oh wait, I'm sorry. Let me change this to the 4th power. Not a square, a 4th power. Okay, put a 4 as your exponent. This is so cool. Well, because I'm a nerd, but okay, here we go. What's being squared here? Okay, now watch. I'm gonna skip a line because I want to kind of leave some room for the thought process here. 16x to the 4th power. What is squared? 16 would be 4 squared, right? X to the 4th power is actually x squared being squared. Hopefully y'all are seeing that, right? Okay, so notice that this is what's being squared here, okay? So in the second thing, 81, now let's kind of do the same thing. What's being squared? Well, 9 would be being squared, right? So let me highlight that with my blue. Notice that these are the two things that I'm going to add and subtract in the parentheses for my factorization. So when I go to factor it, I'm going to go ahead and just tack on, put a plus and put a minus, right? Because there's a difference of two perfect squares. Just go ahead and bring in that 4x squared and the 9. Just kind of chug them in there. 4x squared and then 9. Added and subtracted, just like before. In those previous two examples, you know, keep it simple. Keep the process in your mind. You know what a square is, but keep this process in your mind. Now, we're asked to completely factor generally, okay? And I told you in that step 3 up above, I said, you know, to check your leftovers, check what your factorizations are to make sure you can't factor some more, right? Well, what you need to do here in this case is look for, when you have the difference of two squares, you kind of always want to kind of get in the habit of eyeballing this difference part of the difference of your answer. And what is this now? Just the addition between these two numbers is going to be done, right? But look what happened. The squares were squares. So this guy, when you have addition between two perfect squared numbers, by the way, it's done. It's prime. You cannot factor it any further. So what we'll do is we bring that down. So I'm just going to bring down the one with the addition. Okay. Now this guy, the second one, the subtraction between the 4x squared minus 9, this can be factored again. Okay? So this also, again, it's a difference of two squares. So let's kind of write that out, okay? How do we do difference of two squares? We open two sets of parentheses to factor it. One is a plus, one is a subtraction. And you say, then, what is being squared? What's the square root of the first term, square root of the second term? So we have what? This is what being squared? 2 and x. So 2x is what goes inside here, right? Inside the parentheses. And then let me just put the 9. Let me just write that. Oh. It's hard to make out the red and the gray whenever I write with those colors. I can't see the point, pencil point. So then we'll put in a 2x and a 3. That's the square roots, right? You put in the roots of what's being squared, right? And now it's completely factored. Now we're done. Yay. Okay. So this would be my answer on this one. Now that's completely factoring. You want to check to make sure every part, every factor in your factorization is itself completely factored. So that's just kind of something you keep your eyes on. Let me kind of bring out y'all's questions over here. I'm taking out the question box. Where are y'all? I think, oh, that's right, I left it open down here. Let me see about that. And see if y'all put some more questions in here for me. Okay. So I noticed in lecture 10 homework, like the last two, it says in each polynomial find the greatest common factor of the terms. What that's asking you to do is it's just saying what would you factor out? What can be factored out, if anything? Okay. All right. So just kind of keep that in mind. Number 20 is kind of a trick question. There's addition between those two things. So you can just remove the parentheses in number 20. Okay. So there you go. You got the 411, the hint on that if you came to our webinar. So y'all are awesome. You see what I mean? Yeah, you can just take those parentheses out. If there's addition between the two parentheses, you're golden. Disregard the parentheses and then read the directions again and do the problem. Okay, if there's subtraction between though, you have to distribute that negative and then you're good. You can take out all the parentheses. Okay, so find and simplify a product. I'm noticing on number 16, I'm noticing in 16 that there's subtraction between two things. So I'm going to do one similar to 16 to kind of give you guys the idea of that one. And let me see, I see exercise 10. Did we do one like that yet? Yeah, okay, so and then I'm going to do one like 10. Okay, so let me do one like 16. I'm kind of working my way backwards, but it looks like that's what they're doing, but that's cool. All right, so I didn't forget you for 10, okay. So let's kind of come down, let me put that up. Okay, give me some room to write. Okay, move that down there. Okay, let me get back down that. Okay, so here's what I'm talking about. Okay, so we're wanting to completely simplify. Okay, so the directions example reads to, let's see, yeah. Okay. My directions would say this: perform the indicated operation. Indicated operations, if it says add, add it. If it's indicating to do multiplication, multiply it, you know, do what it says to do. Indicated operation, which is basically what they're kind of saying, not so many words. Okay, so, and this is a nice general way for me to put like a ton of examples up at one time. Okay, so let's say, let me get this. Let's find that problem. Okay, all right, here it is. All right, where are you? Just had it. Okay, let's have this one here. Where's my pinpoint? Okay, so we will have 4a, that's an a, sorry, minus 2. Okay, and then a plus 1 minus 3a. I'm sorry, I keep wanting to write an x instead of an a. This is an a. 3a plus 2 squared. Okay, so this one actually doesn't look exactly like the one in the homework, but it's very parallel to number 16. Okay, so what's being indicated means follow your order of operations. Okay, in 16 saying find and simplify means follow the order of operations and then make sure your answer is completely simplified. Okay, be sure you guys understand what you are being asked to do, and if that is ever an area of confusion, that's one of the cases where you definitely can ask me to help you, whether you're taking a test or doing your homework. If you can't understand your directions, then there's this, you know, what are you going to do? So ask me. I will happily explain your directions to you if you're confused about that, okay? So let's go ahead and do this. We'll FOIL first, okay? First is what? We'll have 4a squared outer plus 4a inner negative 2a and last minus 2. Okay? All right, so now we're going to come on over here to the second part, and we can kind of underneath if you want, since I think you guys are kind of getting to the point where you're okay with this. I'm going to write a little note. I'm writing it out twice because it's squared. I'm going to FOIL it from here. Important thing to note, okay, is this. You have subtraction between these two things, okay? Ouch. I'm trying to write that a little thicker. Make sure you do this. You got to bring that down. That is not part of that multiplication, right? We don't have to add and subtract till last, till we're done with the multiplication. So in order to exclude that subtraction from the FOILing I'm about to do, I'm going to open a set of parentheses, and in there is going to go the result of my multiplication, okay? So kind of keep that from step to step. You want to kind of learn to keep that isolated. So first, we're just going to FOIL this, or multiply the binomials. So what will we have? We'll have 9. If you do it correctly, you should have 9a squared plus, let's see, 12a. I'm going ahead and doing the whole thing in my, I did the step in my head. Okay, everybody okay with the 12a? That's for my outer and inner. I had 6a and then 6a. It gave me 12a. Okay, so there you go. That should be what you have there. Okay, that's the result of that squaring 3a plus 2. I'm trying to make my 9 a little prettier. It's kind of gross looking. So let's see. Now what do we do? Now we can go to that subtraction. Okay, fix that. So what I'm going to do is bring everything down. 4a squared plus 4a minus 2a minus 2. And I'm going to proceed to take the opposite of 3 terms in my set of parentheses. Make sure all 3 things become the opposite sign, right? Okay, inside the parentheses, this 9a squared is positive, so be careful, okay? This is going to, it'll wind up being negative. So a minus 9a squared. Actually, they're all positive, so they'll all become subtraction. Okay, Now that helped me to eliminate that set of parentheses, okay? But you have to handle that way. If you're subtracting a multiplication, a product like that, and that goes for the homework problem similar to this too, you want to handle that in 2 separate steps or you can really annihilate the signs and your answer goes kaput. Okay, hold on now, I'm not done. We still need to combine like terms. Okay, what I'm going to do here is I'm going to put it in descending order and combine like terms at the same time by looking for the term with the highest exponent on a, and that would be the square. So 4a squared and minus 9a squared would be what? Negative 5a squared. In your answer, it's okay to have that negative leading coefficient. We're not being asked to factor this. We're asked to multiply it. So you're okay with the negative leading coefficient here. Don't worry about that yet. Okay, just when you go on to factor, that's when you worry about that. Okay, so I didn't have a chance to combine my 2 middle terms over here, so we can do it now. No big deal. 4 minus 2 is 2, and then minus 12a. So we have positive 2 minus 12. So negative 10a will be that one. Let's go there, put that down. Where's my pinpoint? Oh, I'm going to grab my pen. There it is. So minus 10a. And then negative 2, negative 4, we minus 6. All right. So let me get to that other one. Okay, so while I'm in perform the indicated operations, I'm going to do a long division problem with y'all. Okay, so long division example. Y'all need to have at least one example with long division here. Yay, at least one. Okay, so let me get that one, the good one. Let me look at what they gave you guys in this assignment here. And yeah, okay, it's not too terrible. All right, so here is my long division problem. I want to get one that has a remainder so that you guys will know what to do with it if it has a remainder. I might even do 2 of them. Let's see. Okay, so let's do B. Let's have this. Let's do, okay, where are you? There you are. Okay. Okay, there it is. I lost my place. 3x cubed minus x squared plus x minus 2. Okay, so we're going to take this guy, and we're going to divide it by x plus 2. Okay, so our divisor is x plus 2. In case you've forgotten, divisor, the denominator, and the divisor is kind of synonymous. That's x plus 2. And then our dividend, whatever we're dividing into, we're dividing into is the dividend. That's the longer one up front. Okay, so let's kind of set it up as our long division, okay? This will look like this. So we'll have x plus 2, and leave yourself some room on top and bottom, right? Here's the division house. 3x cubed minus x squared plus x minus 2. Okay? And so wait, give me a second. I'm going to actually give myself some room to the right as well. Yeah. Okay. So here's where we begin. We begin by saying x goes into 3x cubed how many times? Okay? And so what is that going to be? 3x squared, right? Notice I'm going to put that over the x squared. I'm lining up my terms with the same exponents, okay? Okay, so notice all my x squared terms are going to line up eventually, x's and constants that will line up. That's important to know when you're coming to the end of the problem, by the way. So then what happens? Then we take this number we got here and it gets what? distribute it into that, and that answer goes here, right? Okay, so let's go for it. Let's do that. Okay, so now 3x squared times x is going to be what? 3x cubed. 3x squared times 2 is going to be what? Plus 6x squared. So we'll have plus 6x squared. Okay, so now what we do here, this is extremely important, okay? And it's so important, I'm going to use red. Put this sucker in parentheses and subtract on the outside. Every time, do it just like I just put it, because that will help you to get it right, okay? So we're trying to subtract all of it, not just a piece of it. Okay, and then what do we get? All right, notice, and you can do this in your head, okay? I'm not going to mark it all up and try to change signs in here, okay? I'm just going to do it in my head. I'm going to say, because I've written it like I did, like I have it here. So 3x cubed minus 3x cubed is 0. It should zero out the first term here. And then negative x squared, that's negative 1x squared, right? All right, what do I have there? Oh, wait, let me get my pen writing correctly. Get my black pen. Okay. This was a plus, by the way. Okay, by the way, 3x squared. Yeah. Okay, this, I didn't just change that. This is what it was when I put it there. Okay, so we're going to have negative x squared, and it'll become minus 6x squared, which becomes what? Minus 5x squared. So tap on your x squared, don't forget. Okay? Let me make sure I did that correctly. Did I? Let's see. No, negative x, and no. Did I do it right? No, I didn't. Hold on. I'm going to do it right now. It's going to be negative x squared and minus 6x squared. I'm sorry. It should be negative 7x squared. Thank you very much. That's correct. Okay. All right. So yeah, it can be a little confusing. I don't recommend coming in and changing the signs down here on this thing with the negative. I recommend putting the parentheses and the negative on the outside and do what I just did. You come on the side, you know, and that's, come do some scratch work on the side. Okay? And then you come in and put that if you have to. Okay? Get this out of the way because we need to bring something down. Remember, in division, the same thing as for just numerical division, we bring the next term down. So we will bring that x term down. Okay, let's see, where are you? So this guy comes down. Okay, so we have plus x. Okay, so now we start over again, all over again. X goes into negative 7x, right? So x goes into negative x squared, excuse me. How many times? Okay, so how many times? So we'll have negative 7x. That's it. Should line up over this x term, by the way, and it does. It lines up over the x term pretty well, especially if I write a little smaller. Okay, and so next step is to take that negative 7x and distribute it into our divisor, right? We want to take this guy and bring it over and around, right? So negative 7x times x is what? Negative 7x squared. And go that way again. Negative 7x times 2 is minus 14x. Okay, I see questions. Look, now I'm coming to you question in a sec. Okay, let me just get this out. Put the sucker in parentheses and subtract, right? Like we had said before. Parentheses, subtraction. Notice both of these are negative, but then once I do the subtraction, they go positive. Let me see the question. 7x squared. Michelle, are you talking about on top, in the answer portion for that question? This is correct what I have here so far. We're okay, by the way. Okay, so So far we are good. Okay, yeah. I didn't know what you're asking me. Oh, are you helping? Okay. Okay, I got your answer. Okay, you're cool. That's good. All right, so let's continue now. Let's go ahead and do the subtraction and bring down the last constant term. Okay, so next, let's see, let's draw a line. Now you guys work ahead of me while I'm trying to see my ink pen. Y'all keep going because I want to see if you can get through the last round of the algorithm. An algorithm is a method to the madness, basically. It's something, it's a sequence of operations that we repeat over and over again to achieve a desired outcome, right? So we're trying to achieve division in this case, and there's so many steps, right? For every term we have to go through this division algorithm. And so you guys, if you notice, in other words, it's a cyclical operation. It goes through cycles, and we have one more cycle left once we finish this subtraction. So, and we are running out of time, so let's kind of move on here. So anyway, negative 7x squared plus 7x squared is 0, x, and then plus 14, we're going to have 15x. Bring down your minus 2. Now finally, I guess I'm not going to be able to let y'all go through it too slowly. X goes into 15x. We're going to have what? Plus 15. Now watch here. I'm going to go through this like I'm going to whip through this really fairly quickly. 15 times x is 15x. 15 times positive 2, look at this, be careful, look alive, 30. Parentheses, subtract. I forgot my x on 15. Okay, so now 15x minus 15x. What happens here is I'm going to have a positive value here, okay? So I'm actually going to, oh, I'm sorry, not positive. What am I saying? I'm going to have a minus 32, negative 32 remainder, right? Okay, what do we do with that? Okay, so check this out. Let me come up top and I'm going to put the answer where it goes, okay? So if you notice, I'm writing up here up top where the answer would be. Okay, let me give some room. Yeah, thank you. My answer would be, and I'm writing it up where the question was asked, okay, so we'll have 3x squared minus 7x plus 15, and then what we do is we take the remainder, okay, and we put plus negative 32 over the divisor x plus 2. That's how we do our remainder. Okay, there are sometimes they'll let you write the answer like this, and just put a r, negative is equal to negative 32. Depends on the book, really. Okay, I'm sure that could be a colon too, or colon negative 32. Anyway, at any rate, this is the answer. Okay. I want to do one quickly, like the one you guys asked me about with the factor and cancel. So here's that. Okay. Let me do that. Okay. So I got that right here. Here we are. Let's see. Okay. Alrighty. Okay, come on. Where are you? Where are you? Okay, I have it. Here we go. That's the one right here. Okay, so last example of the day, let's say factor and cancel. Okay, make sure it's, in other words, factoring means simplifying, right? Canceling means simplify. So really the directions could say simplify. So just FYI, x squared plus 9x plus 8 over, and let's say, let's have, hold on it, okay. Oh, well, where was I? I think I lost it. No, I got it. X squared plus 7x minus 8. Okay. So what you're going to do is you're going to take each of these separately, your numerator and your denominator. This is the best way, I think, the most organized way to do this is to kind of Make sure you're very good with your scratch work. We're going to take that numerator and we're going to factor it, okay? So what I'm going to do is I'm going to kind of come out on the side here and factor it. Just make sure if you wind up doing scratch work, you know, that's what you need to do. You need to take it on the side and do scratch work and then come back into the organized problem. Okay, so to factor this, we need to find the factors of 8 that would add up to 9. What? 8 plus 1, right? Check this out. This is what I can split up my middle term into in order to, or my outer inner multiplications would add up to. In other words, I should end up with an 8x and a 1x, right? Okay, to get my 8 at the end and to add up to 9. Check it out. So I'm going to stick a 1 here and an 8 here. Now they add up to 9x, right? So put your plus signs in there and you got it. Okay? And always check. You can always, you foil it back up to check it and make sure you got the correct factorization. If anybody wants more videos on just factoring trinomials, let me know. I will most definitely tack up a lot of videos on the YouTube channel if I can't make any myself. Actually, I have a very good video I'm going to go post right after this. It'll help. Okay, now let's take that x squared plus 7x minus 8, okay, on the side. We'll take that over here, x squared plus 7x minus 8. What are some factors of 8? Now, since it's a difference, and since 8 is subtracted, I'm going to say whose difference is 7. Factors meaning 8 is what? 1 times 8, right? 2 times 4. But I want to see these same numbers I'm writing, these pairs, subtract them, right? Look, 8 and 1 have a difference of 7. So that's kind of what we want to use for this problem, okay? Check this out. I'm going to use an 8 and a 1. Okay? In other words, to get 7x, I would like to have a positive 8x and a minus 1x, right? So let me try that. Let's try having a positive 8 and a negative 1. Does this work? X squared. Yes, 8x minus 1x gives me that 7x. And then 8 times negative 1 is negative 8. What I'm using is called the AC method, okay, for factoring. Okay, to factoring, okay, for factoring trinomials, okay. That's what you can look up, all right? And that's what I'm going to post too. That's for factoring trinomials. All right. Anyway, let's come back to the problem. We'll have x minus 1, and notice I'm swapping I'm letting x minus 1 come first. That's okay because multiplication is commutative, right? It's the same thing. Okay, I'm doing that so I can line up the x plus 8s and show you that a number over itself is 1. And we talked about that before too, that's equivalent. So this is not factorable. You can only you can only cancel amongst factors. And these guys are separated by addition in the numerator, right? These are whole binomial factors. So in other words, the whole binomial would have to cancel with another one of its own. I think I just accidentally did that. Okay. So the whole thing would have to cancel. It's tempting to want to go cancel those x's and the 1s and all, but that is not possible here. This is way different than if I had something like 2x over x. This is different, right? The problem down here, these guys, this is multiplication. You can cancel here. Factors can be canceled in fractions when you're simplifying or reducing, but not terms. Do not go canceling the x's out of this answer. This is the final answer the way it's written here. This is done. Okay, guys, and it looks like we're done. It looks like we ran out of time. But I'm glad we got some of this stuff covered. I think you guys are going to do fine. I'm going to go post some new videos on the YouTube channel to help you guys out with this, with the factoring of the trinomials and a lot of your other midterm stuff. If there's not up already, there's lots of stuff up there that's very good. Okay, and I'm going to have to go through and see if there's some stuff that nobody seems to like. So I'm only posting videos that are particularly helpful to our class. So go check it out. There's a lot of videos on there. It seems like a lot, but there's a lot of good stuff on there. It really is helpful. You guys have a great day, okay? Be in touch with me. I will be in my office this afternoon. I found the value of 1649 from this polynomial. Okay, Viv, let me write that down and come talk to me in the view office, okay? Why don't we we'll put that one in the office in a minute, okay? You guys, if y'all want to come to the office right now, I'll be in there for like a few minutes, and then I'm gonna get some lunch in a little bit, and then I'll be in there longer, like after lunchtime, okay? But y'all join me in the office. Y'all know where it is. Go to the general forum and find that post. It's vyew.com, but there's a link in the general forum that will take you straight to our office. And come on, come get some help. We'll continue this session too. Bye guys. Talk to y'all later.